So hi everyone, welcome back to another video on my YouTube channel. Hope you all must be doing great. Today we'll be starting a new series of sorting algorithms. We'll be covering the entire sorting algorithms in number of videos. In today's video, I'll be covering the theoretical part of sorting algorithms, and so basically it's going to be an introductory video. Right? So let's get started. So, our journey for understanding the sorting algorithm starts from understanding what is an algorithm. So, as you can see by definition, it means it is a step-by-step procedure for solving a problem or achieving a specific goal. It is a set of instructions that are followed in a specific order to achieve a desired outcome. So, let's understand algorithm with a real-world example. Suppose if you want to cook something and you don't know how to cook that food. So, in order to achieve this specific goal, you need a recipe. And your recipe is going to be your step by step procedure that will tell you what to do, how you will be approaching towards your goal in a step by step manner. So, in short, you're following the step of instructions that is your recipe in specific order to achieve means to cook your food. Alright, so let's move further. So an algorithm is judged on a number of parameters for enhancing its performance. Suppose if your recipe is written in a manner that it takes a lot of time to cook your food, or there are a number of unnecessary ingredients written on it. So is it an efficient recipe? No. So there is a similar case with algorithm that affect the performance and efficiency of it. Over here, it's been written sorting algorithms because we are talking about sorting algorithms. But the performance and efficiency of algorithm has to be kept in check in order to achieve the task efficiently. So, so here comes our main topic, that is what is a sorting algorithm. So basically, these are the methods that computer use to arrange a collection of data in a specific order. You'll get a clear picture of sorting algorithm in the next slide. So let's now understand how sorting algorithms work. So this is a very basic example. I hope you all must be able to understand that. We have a collection of data, collection of numbers, which is having 10, 60, 30, 20, 40, 50. And after performing sorting on it, the sorted data will be having is going to be 10, 20, 30, 40, 50, 60. So this is the basic goal of a sorting algorithm. So as you can see, it's arranged in ascending order. So through this, we can understand the basic goal of a sorting algorithm. So sorting algorithms can be classified in number of types. In this series, we'll be covering the five important sorting types, which is bubble sort, selection sort, insertion sort, merge sort, and quick sort. We'll keep our focus revolving around these five algorithms. So let's start with the first type, which is bubble sort. Over here, we can see that it's written bubble sort is one of the simplest sorting algorithms. It is one of the simplest sorting algorithms that we are going to study, right? So its working has been explained as it works by repeatedly swapping adjacent elements that are out of order until the entire array is sorted. So two words that you have to keep in mind, that repeatedly swapping. Repeated swapping takes place in this algorithm. So next, it's been mentioned that the algorithm passes through the array from left to right, comparing each pair of element and swapping them if they are in wrong order. I'll show you a clear picture of it in the upcoming slides, but first let's discuss on what is its time complexity. So the time complexity of bubble sort is O(n) square. As over here you can see it's written O(n) square, where n is the number of elements in the array. This means that the algorithm becomes slower as the size of the array increases. Bubble sort is not very efficient for large or nearly sorted arrays. So that's why we don't generally use bubble sort, but still it's important. Bubble sort is important for laying the foundation of our understanding of sorting algorithms. So let us now see how it works. Here you can see I am having an unsorted array, or you can say an unsorted collection of data. So I want to arrange this data in ascending order, meaning the 60 should be at last, 10 should be at first, and in between 20, 30, 40, 50. This should be the order. So firstly, we'll compare 10 and 60, the first two elements. As you can see, 10 and 60 are first two elements. We'll compare the position. Are they at correct position? We find it yes. It is forming ascending order between these two. So there is no need of swapping. So we'll do nothing. The same operation would be performed on next two elements, that are 60 and 30. So what will happen? 60 and 30 would be compared. We would find that 60 and 30 are not in ascending order. So we need to swap them. 60 at the place of 30 and 30 in place of 60. So after swapping, the order would look like this: 10, 30, 60. Now the next two elements would be compared. Are they in ascending order? 60 and 20. Are they in ascending order? No, they are not in ascending order. So we need to swap them. The array becomes 10, 30, 20, 60. Again, we need to compare the next two elements. Again, 60 and 40 would be compared. Since 60 is greater than 40, now the array would look like this. Now the comparison of last two elements are remaining. So we need to compare them also. 60 and 50 are compared. They are not in at their correct position. So swap them. So ultimately we'll get 60 at its correct position. So the last position has found its correct element. So the first pass is complete. Now the largest element 60 is its correct position. As you can see, the largest element 60 is in its correct position at the end of the array. Repeat the same process for the remaining elements. So on this last position we have placed 60. Now similarly this operation has to be performed for all the positions till this position has found its correct element. So this was the working of bubble sort in brief. After the first pass there would be a number of passes, and after this operation is completed, our array would look like this, which is in ascending order. So this was the brief working of our bubble sort algorithm. So let's understand selection sort.